The movement of a precessing vector is governed by a fundamental relationship where its rate of change is dictated by its interaction with a fixed axis. This interaction ensures that any change in the vector's position is always directed perpendicularly to both the vector itself and the axis it is rotating around. Because the vector is constantly pushed sideways rather than being pulled towards or away from the center, it undergoes what is known as pure rotation. Throughout this motion, two specific properties remain entirely unchanging. Firstly, because the direction of change is always at a right angle to the vector, the length of the vector remains constant. It does not grow or shrink as it moves. Secondly, the projection of the vector onto the fixed axis is conserved, which means the angle between the moving vector and its central axis never alters. These constant properties result in a distinct geometric pattern. Since the vector maintains a fixed length and a fixed angle relative to the axis, its tip traces a perfect circle in space, causing the vector to sweep out the shape of a cone. This specific type of circular motion around an axis is the defining characteristic of precession. The speed at which this rotation occurs is known as the angular frequency. This rate is determined by the strength or magnitude of the constant axis. The greater the magnitude of the axis vector, the faster the precession will be. This rotation remains steady and constant as long as the axis itself does not change. In the physical world, this narrative describes essential phenomena such as the wobble of the Earth's axis over long periods or the behavior of a proton spin when subjected to a magnetic field, often referred to as Larmor precession. Visualizations of these concepts typically use a stationary red arrow to represent the axis and a blue arrow for the precessing vector, with a yellow line tracing the circular path to make the formation of the cone visually clear to the observer. These models confirm that, regardless of the starting conditions, the vector's length and its angular relationship to the axis are perfectly preserved.